Hello everyone, and welcome back to part 3 of our series on how to build an IFT service from scratch. In the previous video, we connected our locally running fast API server to a newly created IFT service, and we ran through the endpoint tests to the point where the status endpoint was successfully passing the test. This only took us about 30 lines of code, but we will be expanding it quite a bit in the next couple of videos because we will be talking about user authentication. Before we jump into the code, I want to spend some time and discuss what authentication means for the user. On IFT, there are two types of services when it comes to authentication. Some services don't require any, and most services do require end-user authentication. If we look at something like the finance service, this does not require authentication at all because it is serving publicly available data. So when we connect it, nothing is asked of the user. It just connects. Same goes for the Weather Underground service, the RSS feed service, and a few others. There is nothing to do for the user besides just clicking the connect button. And in fact, for new users, I believe we are connecting these automatically when the account is created. But like I mentioned, these services, they fetch publicly available data, like the weather forecast in a given location. It's going to be the same for everybody. The price of a security from the finance service is going to be the same, and the RSS feed URL will give the same data for every user. There's nothing user specific about that. But most services work differently. You either have a device like a smart light bulb that you own, and you have an account with the service that made the bulb. And when you want IFT to turn on the light bulb, IFT needs to know how to identify whose light bulb needs to be turned on for the service. That's where authentication comes in. Same applies to internet services that have user accounts, and this is actually the example that we are using, the To-Do app that I have. It has the concept of a user account. Each user has their own to-dos, and they can complete their own to-dos, but they cannot complete somebody else's to-dos or create a to-do for somebody else. So that's where user authentication comes in. To demonstrate real quick, if we go to the Twitter service and then try to connect it, the first thing we should see is a redirect to the Twitter login page. You won't see it right now because I'm already logged in this browser. But if I was not logged in, I would see the Twitter login page first, and then I would be redirected to this consent screen. As you see, this is on twitter.com, so this is not something that IFT hosts. This is your apps or your services authentication flow. And this consent screen is important, by the way. This is something that the IFT team will look for when they review the authentication flow for your service before you can publish it. There needs to be some sort of a consent that's presented to the user, either on the login page itself before the credentials form, or as a separate consent screen, like the Google and Twitter and Facebook services do, where it's spelled out exactly what the user is connecting and what sort of permissions the user is granting to the IFT service. You don't have to go to this level of detail for every single service that you build on the platform, but it helps build trust between the user, IFT, and the service or product that you provide. So when I authorize the app, I am redirected back to IFT, and the service is connected successfully. Now I can create applets, and when the applets run, or when I create more applets, I do not need to connect Twitter again or use my Twitter credentials anywhere else after this point. What IFT has now is a set of tokens, either one token or a set of tokens depending on the auth scheme that is used. And it can now call the Twitter API on your behalf with a token that identifies the call as made on your behalf or on behalf of your Twitter user. Sometimes tokens are also refreshed in the background, but we'll get into that in a bit. So let's go back to our IFT service. And under authentication, right now it says my API does not require authentication. The two other choices is my API has users with non-expiring access tokens, and users has expiring access tokens with refresh tokens. We'll pick the last option because it's more secure and more popular these days. And here are all the fields that we'll need to fill and provide the IFT service with. We'll discuss them in more detail shortly. Now, let's look at the documentation that's available for the service authentication. On the documentation portal, we have an overview of what is involved in service authentication. It mentions that there are two steps. One is the authentication flow itself. This is where the user enters the credentials, the redirects happen, and at the end of that, it receives the token or a set of tokens that it stores in the database. And then the second part here, this is calling your API and the special /user/info endpoint with a newly obtained token in order to get the information about the user, so we can store the name of the user and the ID of the user as reported by your API endpoint. A note here that it says that if the service interacts with user data, authentication is required, and no workaround such as asking the user to enter an API key when setting up a trigger will be permitted. This will not be approved, and you will not be able to publish triggers or actions that use similar workarounds. So authentication is pretty much required for the vast majority of services on IFT. The authentication flow itself follows the OAuth 2 standard, the code grant flow, I believe is called, and there's a link to the relevant RFC that describes the OAuth 2 framework. It's a pretty large document, and there are multiple different paths and flows that it follows, or that it offers. The one we are interested in is the authorization code grant, and also refresh tokens right here. It follows this specification pretty closely in how it expects your service to implement authentication. I think I'm not going to go into all the detail that is described in this document, because what we will be doing in this tutorial is we will be using Auth0 as our authentication provider. We are not going to build the Auth 2 authentication flow from scratch. We are instead going to rely on Auth0 to store our users and manage them for us, implement the login screen and the consent screen and all of the endpoints that are needed to exchange tokens and obtain them in the first place. Now, Auth0 is used here as an example. There are other similar services offered by AWS. They have a product called AWS Cognito. Microsoft Azure has Active Directory that has a flavor that allows you to use it for end-user authentication as well. So there are multiple different solutions that you can use in addition to building everything from scratch. We'll be using Auth0, and I just wanted to demonstrate how relatively straightforward it can be to add authentication to an IFT service using something like Auth0 or AWS Cognito, because I've seen that implementing authentication from scratch, especially if you haven't done it for an API in your product in the past, it can be a substantial task and a big undertaking. Let's jump into Auth0, and I already have my main to-do app here under applications, but instead of connecting to the same app, I will start from scratch and I will create a regular web application just to show you all of the steps involved. I will grab the client ID and the client secret because if you remember, I have this form that I need to fill out to turn on authentication for my IFT service. Now, the authorization URL in Auth0, if we scroll all the way down on the settings tab, we have advanced settings, and under endpoints, I have a set of URLs that are handy for copying and pasting into IFT. So I need the authorization URL, and we'll add some parameters like scopes later. And I also need the token URL, the auth token URL here. Now, the redirect URL is something we need to put into Auth0. So it's the URL that Auth0 needs to redirect to after successful authentication. So it needs to know it's an allowed callback URL. And there's a special section here, allowed callback URLs. And I will save the change here. And one other thing that needs to happen is we need to provide demo credentials. These are the credentials that the IF team can use when they review the service so that they connect it and run the authentication tests. I'll use my test user here and save the changes. With my new authentication settings, I have a section that was not here before, authentication test. This is a test suite that will run through all of the calls that IF makes during the life cycle of a service. So let's try it and see what happens now. There we go. So this is the Auth0 login screen. It was built for us when we created the app. I will use my test user here and then click continue. And we see that the first part worked right away. So we got the authorization code. Auth0 did its job and redirected back to IFT with the code. And then the second step failed because it tried to obtain the token with the access code and something did not quite work here. So all Auth0 actually sent us is a token with no scopes, some expiration date, and the token type is a bearer token. So it looks good, but the refresh token was not provided. Let's see if we can fix that in Auth0. I also want to inspect the token that Auth0 sent us. So if I copy this, and then go to jwt.io, here on the front page, there is a debugger that can decode a token for us. In this case, I'm not getting any payload. I just know that the token was issued by my app. And this is because we're not asking Auth0 for anything extra to be put in the token. But we need to do that because we at least want to see the user ID and we want to have the refresh token as well. Both of those we can tell Auth0 to provide through the scope in our authentication URL. Back to authentication, and in our authorization URL, we want to ask for the following scopes. We want the email and profile information. OpenID is to power things like login via Google, I believe, which is also supported by Auth0 out of the box. And offline access is what will give us the refresh token, I believe. So let's save this and see if we move forward just a little bit in our authentication tests. Since I'm already logged in, I don't think it will ask me to do that again. And we still see that the token is red. There's no refresh token still. So let's see if we can do anything about that in Auth0. Over in the application settings in Auth0, one thing I forgot to turn on is refresh token expiration. So it looks like Auth0 cannot issue perpetual refresh tokens, so it needs to have some expiration and absolute lifetime. So if I turn this on, save the changes, Let's try authentication tests one more time. We see that a test retrieved the code as before, and we requested the access token, and this time this test is green. Let's see what happened here. Alright, we have the access token and the refresh token, so IFT can now store those and use them as needed. All green here when we refresh the access token. The user information is red because notice how it's calling where it thinks our API is. So it's not calling Auth0, it's calling our API, which is not running at the moment. So it did not get anything. And it was successful in refreshing the access token, so all green here. One last thing I want to do before we move to our code is change a setting in our Auth0 app so that the refresh tokens are rotated. This is entirely up to you and how you want this to run and how you can implement it. If you're using something different, you can provide a refresh token that is perpetual, or you can rotate refresh tokens. So anytime if it calls for a new access token, using a refresh token in the call, and then you can return a new access token and the same refresh token, or you can rotate both. If you do that, it will store the new values for both tokens. So let's turn this on for extra security. And we don't expect to hit the expiration ever because it will be refreshing tokens long before this time expires. So we save the changes and we are going to run authentication tests one more time. Okay, so the refresh token call was successful, but notice how the last item is red, but it used to be green. Ensure all the refresh tokens does not expire immediately. Why is this important? And why was it not red before? So before the last change that we made, the same refresh token was used over and over again. So when IFT tried to refresh the token again, it just used the old refresh token. It succeeded because it was the same, it was not rotated, but now Auth0 is rotating refresh tokens. So when this call is made, well, let's compare and see first what we get as a set of tokens. So when we first exchange the code for a set of tokens, we have a refresh token. It starts with v1, then ends in QTM. Now, if we go to the call where the access token was refreshed, we can see the refresh token v1 QTM. So we IFT sent the refresh token it received the first time. But now in response, Auth0 is returning a new refresh token that ends not in QTM but in something different. So IFT saved this, but then the last test, it tried a refresh token that ends in QTM, so the original one that we got the first time. And obviously this one failed because Auth0 has already refreshed the refresh token as well. So this one is no longer valid. But this last test needs to be green, and why is this important? The refresh tokens, they're handled in the background without any user interaction. That's why Auth0 calls the scope offline access. When it needs a new set of tokens, it uses the refresh token that it stored to make the call to the token endpoint. That call makes it to your authentication server or Auth0. Auth0 refreshes the tokens, but then there is a chance that IFT will not be able to receive the response. Maybe there is an outage, maybe there is a database issue, or most commonly, it can sometimes take authentication servers longer than 2.5 seconds to respond to IFT, and in that case, IFT will drop the connection and consider that a network timeout, but your auth server likely did refresh the token, just took longer. If that happens, then we are out of sync. Your authentication server already has a new token that IFT still has the old token because it did not receive the response or was not able to save the new token. So without the provision that this test is looking for, the only way to recover the connection is for the user to reconnect manually and go enter their email and password and connect again. And we want to avoid that. If there's something that is usually expected to just work in the background without any need to tweak or fiddle with it, fortunately, Auth0 has a setting that can help us here, and it's called reuse interval. So as it says here, it allows some leeway that the same refresh token can be used to request a new access token without triggering what they call reuse detection. I think I will put something like 3600 seconds, maybe a bit large for our purposes here, but I think they should work, so save the changes. And run the tests again. Okay, so we have all of the tests except the user information green now. That's a big part of our job done, and we didn't have to write any code for it. We delegated all of this to Auth0. The second big part is to build this into the service API that we are implementing with Fast API to make sure it can interact with Auth0 to validate tokens that it sends. And we'll do that when we start with the user information endpoint, so that we can make all of these tests green before moving on to triggers, queries, and actions. But I think I'll start with that in the next video. Thanks everyone who made it this far. Subscribe to the IFT YouTube channel so you don't miss the new videos in this series, and I'll see you in the next one. Bye-bye.